Hi everyone, welcome to UTA Planetarium's next live star stream. This is Levent Gurdemir, UTA Planetarium Director and astronomer. I am going to talk about Mars today. Before we start, I would like to make an important warning because there are spam links are posted on the chat window. Do not click on any links in this stream. This stream is not charged. It is free to anyone. You don't need to click any link for that. And especially if something is asking your credit card number or personal information, you are on the wrong website. We are not asking any information with that. So with that said, what about Mars? Well, when I looked at the title of this talk first, it said Mars in opposition. So I felt like I am going to debate with this gentleman over here. No, that's not the case. So the opposition is an astronomical term, and we use it for a special configuration for planets. For example, let me switch my view to the presentation. So I need to show you the opposition picture when we call a planet in opposition. And it is basically when the two planets are on the same side of the sun and they are lined up. And in this case also the two planet is in the same configuration. So we are preparing a picture to show, and I'm not sure why we have Mars spinning over here. We should be seeing some, oh, that's image. So the opposition is very simple. The two planets is on the same side of the sun and they are lined up with the sun. And in this configuration, two planets are too close to each other, the closest position, and that's why this is a special point or special configuration. So as you can see, the Mars have opposition with Earth roughly in every 2 years. So because that happens every 2 years, that's not a very important event. What's important about the Mars then? Well, most of the time, the common question people ask me is there life on Mars? So let's address that question. And this becomes particularly important because there is also a recent theory that's suggesting the life may be started on this planet, Mars, in the solar system, and then migrated on Earth. So that's possible. That's a theory. We'll look into that in detail. But let me address the first question, which is there life on Mars? Well, the short answer is currently there is no evidence for Mars to have any life on the surface. But when we look at the conditions, so why Mars is coming up, why it's not like, for example, another planet, Venus or Jupiter, we questions about life. That's because when we look at the planet, the life condition of a planet, so basic thing is, or most important thing for us is liquid water. So as you know, the liquid water, the water freezes at 0 Celsius or 32 degree Fahrenheit, and the water boils and eventually evaporates at 100 Celsius or 212 Fahrenheit. When we look at the solar system, so we define a zone that the water can be liquid on a planet, and we loosely call this zone habitable zone. This is not the only condition for life, and it's very complex, actually, very complicated for if we list the conditions for life. But Mars and Earth fits into this zone. Mars being on the little bit edge of this zone on the cold side, because after you pass where Mars is, the conditions become too cold to have a liquid water, and if you go on the other side, the conditions get too hot for liquid water, and Venus is out of the question. Venus is too hot for liquid water. We also need to note that this zone was closer to the right in the past, in the early solar system. We are talking about 2-3 billion years ago. The Earth was on the hot side of this zone and Mars was more towards the center because our sun ages, and as the stars age, they lose their power. They diminish the power a little bit, the heat and light power. So, well, that was always a theory that the Mars maybe in the past had life or maybe currently have life, and that was not interesting until year 1996. So something important happened in 1996. Geologists picked up a rock from the continent of Antarctica, and it's called ALH 84001. That rock is coming from Mars, and that was formed with the Mars 4.5 billion years ago. And then until about 16 million years earlier, that rock launched from the Mars surface. So that sometimes happens, and it is probably an asteroid impact. Asteroids hit on planet surfaces and then they launched rocks into space. And in the next 16 million years, that rock started wandering in the inner solar system. About 13,000 years ago, that rock fell onto Antarctica. And in 1984, it was found by geologists around the location called Allen Hills. That's why it gets the ALH designation. And 84 is the year it was picked up. It was 1984. And this rock was coming from Mars, it was confirmed, but also it had the minerals of carbon compounds. And on Earth, these kind of carbon compounds only created by microbes. So that's a clear evidence for the Mars had microbial activity in the past. That means it had life. And also this rock had magnetic iron oxide, which is called magnetite. It is also product of bacteria. And that's also gave us the idea that Mars had life in the past, at least before. If you would like to see this rock, it is on display at the Smithsonian National Museum of Nature. You can go and see that. That's itself is not alone. We needed further evidence that the conditions were okay to sustain life on the Mars surface. So next thing to look at is NASA launched a set of satellites and rovers to land on the surface of Mars to explore in detail. Earlier satellites showed some of the pictures that looked like erosion of water. And today we know that the water is clear, water is gone from the Mars surface. But this type of evidence suggests that Mars had water in the past, because this type of erosion can be only seen at the riverbed and a sea floor and similar places. So that told us Mars had liquid water in the past. So what happened to water then? So that's a different story. What happened to water is if Mars had lakes and even seas, and one of the theories suggests that Mars maybe had, just like Earth, 75% covered by water. So this water, the Mars, what we know about Mars is the main difference between Mars and Earth is the magnetic field. So Earth has a strong magnetic field that shields the Earth from a strong destroying, ionizing electromagnetic radiation from the sun. So if without the magnetic field, we wouldn't exist. So what magnetic field does is there's a big particles raining down from the sun, and it traps and then diverts into the polar region, which are the tip poles of the magnetic field. So they are diverted to the polar regions, and because the atmosphere and the polar regions are so close to each other, the particles start interacting with the atmosphere. You see that kind of phenomena when you travel to northern countries like Iceland, for example, during winter. You see these type of phenomena in the sky. It's called aurora. So those are the highly energetic particles coming from the sun and interacting with the Earth's atmosphere. And what they do is, as soon as they touch to the air molecules, they ionize the atoms, and because of that ionization, big energy is released into the air, and that energy is seen as lights like this. But this is also destroying the air too. But on Earth, the rate is not much. We don't have to concern about how much air we are losing through these great lights or the light show. But that becomes important for Mars, because Mars lost its magnetic field about 4 billion years ago. And as soon as it lost the magnetic field, then these harmful rays started coming down and destroying the air on Mars, and just left a little bit today. So there is a very thin atmosphere on around Mars. So that made livable conditions probably not possible. It also affected water eventually, because to hold a water on a planet's surface, it's not an easy thing, because there is some air pressure needed to hold the water in its place. Otherwise, what happens is the water evaporates if the pressure is low. We can actually prove this with a hand boiler that I wish I had it today. In the hand boiler, there is a low pressure glass, and there is a liquid inside. In the regular room temperatures, we cannot make a liquid boil, but if we just even like a little squeeze with our hand creates a little heat in the glass, and in the room temperature, or at the temperature of hand, the liquid starts boiling. So this is what's happening with the low pressure. So if we go from a sea pressure to low pressure, water evaporates and escapes the planet. So this is what happened to this planet, and on this planet we still have plenty of water, and thanks to our air surrounding around our planet for that. As you can see, this is actually a scaled comparison of how small Mars is. There is also a gravity effect. To hold a strong air, you need a big gravity force, and the smaller the planet, the smaller the gravity is. And Mars, to begin with, is not a great planet to keep a good air around it. And some great comparison of Mars. It is Jupiter has a moon, Ganymede, and the Mars size is similar to Jupiter's Ganymede moon. So you can even make a moon from Mars if you take it to some other planet. Question from Janet. Hi Janet, why did Mars lose its magnetic field? This is a puzzling question for scientists. We don't know the answer to that. And also we did a stream a few months ago with Dr. Welling of UTA, astrophysicist. He explained that some of the strange things we observe in the Earth's magnetic field, because the Earth's magnetic field has not been understood well yet. Yet that other planets are still, we are trying to figure out what's going on. And soon we'll have a poll about the time and day of our live streams. If you like this time of this day of the week, or you prefer some other time, you will get the chance to mention us, because we would like to pick the best time for you. This is an experiment we are doing this fall. We started with Tuesdays 3 p.m., but let us know if some other times are better for you, so we can look at the majority of the results, and we can decide if we would like to do the live star streams in a different day. And drop your questions in the chat. As the questions come, I will try to answer them as soon as possible. And let's continue. with Mars, whether there's life on Mars or the possibility of life. This is another evidence for organic compounds, and this time this picture came from Curiosity Spirit and Opportunity rover. So the Spirit rover drilled 2.5 inches down to the rock of Mars, because it had like bigger drilling unit, and it was not only drilling. The rover also had it was carrying a chemistry laboratory with it, and dug up some of the rock pieces and put it in its chemistry lab, analyzed it, and sent it the results. So the results came with as strongly oxidized iron-bearing mineral, which also is a great indication that the ingredients for life is found on Mars. It is not the direct evidence of life, but what we are looking is, for example, we are like all the life on Earth is carbon-based. We are looking for carbon-based elements on the Mars surface to say whether the life can be possible. And it found also sulfur, nitrogen, hydrogen, oxygen, and phosphorus, which are also necessary ingredients. And then another one came from, and this is a relatively newer image taken by a Spirit rover in 2008. This cauliflower looking the rock formations. First, Spirit took this image and sent it to NASA headquarters. That image wasn't important that day, but then later it became important because some other scientist was doing research in the Chilean Sea and formed what saw was a similar rock formation, which was done by microbes. And because of the similarity, this picture became important because apparently this can be also a result of a microbial process on the planet's surface, which gave us another idea that life may have existed in the Mars. So there are more and more evidences found by rovers that the necessary ingredients were existing on Mars surface. Let's come back to the different topic. Well, main question is, once we are looking for the formations of rock, and I would like to go back my spinning Mars thing over here. About this planet, Stephen Banner of the Westheimer Institute of Science and Technology in Florida suggested that evidence is building that Earth life originated on Mars. So this is something new, because we always thought that the life started on Earth, which could be still possible because we are talking about theories. Nothing is confirmed and set in stone yet. Those are all theories, and we need probably another decade or two to come up with some stronger evidence and proof that whatever we suggest is true or not true. This is how the science work is. The theory is confirmed, which is good result. If theory is unconfirmed or the opposite confirmed, it is also good scientific result, because that tells the truth. So so the evidence suggests that the Earth's life may not started on Earth, because this was actually also answers the question, if that's true, that the necessary startup chemicals were not exist on the surface of Earth. For example, we have not understood how the life starts yet, but what we think is we need to have the necessary ingredients for life, like carbon, sulfur, hydrogen, oxygen, and then the scientists think that the two things is necessary, and that two thing is, one of them is a chemical called oxidized molybdenum, and the other one is boron. And we have a boron problem for the history of Earth, because about 3 billion years ago, we think that Earth was all covered by water. And that water is corrosive for many minerals, and the boron cannot exist. But in the past, Mars, it seems like, and we confirmed from some Mars asteroids that the boron existed on the Mars surface. So anyway, Stephen says this form of molybdenum couldn't have been available on Earth at the time life first began, because 3 billion years ago, the surface of Earth had very little oxygen, but Mars did. So that's where oxidized molybdenum comes in. Inserting it or boron element into the mix would help organics make the leap to life. And analysis of Martian meteorite, as we said, confirmed that boron was available on Mars 3 billion years ago. So, and also another point in Mars' favor is likelihood that he said the early Earth was completely covered by water, while the ancient red planet has substantial dry areas, which supports the boron's existence. So regardless, this planet may be the place we start with. And then the question is, how did we get into the Earth? So apparently big, not in the form of big animals or humans at all. And certainly I'm not talking about alien spacecrafts or some interplanetary sophisticated transportation transported us. So if there is any transportation, we are talking about here the asteroid impacts and transportation of microorganisms. So life may not have evolved on Mars even if it did start, but after the life starts in organisms, there may be a possibility that just like the rock ALH 84001 that we talked before, it may be transported in a Mars rock after an asteroid impact to the Earth. And then maybe just incoming organisms evolved on the Earth's surface as the conditions on Earth's surface got better and better by time. And then this is maybe how the life evolved on the surface of Earth. And then the evidence suggests that while the conditions were getting better on Earth's surface, the conditions were getting worse and worse, especially with the loss of magnetic field. The air was evaporating on Mars' surface, and eventually the water evaporated from the surface and exited the planet. And the conditions are, I can tell you, on the surface of Mars, horrible. But still, there may be more evidence, if not on the surface, but underground. And this is the current rovers and the planned missions are investigating on Mars. So the current rovers are trying to dig deeper on the Mars underground. And also there is a recent launch of at least 2 spacecrafts this year, and plus more planned for future. And these rovers, those robotic missions, will search and investigate the deeper parts of the Mars soil, which may suggest and include more evidence for the past life or maybe existing current life on the surface of Mars. And hopefully someday, this is far in question, but when are we going to send someone to the red planet? This is big question, because this is complicated. This is the matter of engineering, and certainly we will plan for another Mars talk with all of you that will cover the missions to Mars, the rovers, what they found, and the future planned missions. There is no date yet for a manned mission to sending an astronaut to Mars surface, but hopefully someday that will happen too. Well, if you don't have any questions, we will continue next week. is there still traces of oxygen on Mars? A little bit, because there's not much left from the surface of Mars. It is colder than minus 200 degrees on the surface of Mars, with very little atmosphere and very little oxygen. So there is still oxygen. The traces of oxygen is still there, but it is not significant. Well, hope to see you, all of you, next week with another topic here at the UT Planetarium live star streams. Take care.